So the S8 Sandbox Challenge, you may find interesting. You may find it a little silly. It's kind of intended to be both. So I'm going to give you two strings of text. One is the second inaugural address by Abraham Lincoln, which is found on the wall of the Lincoln Memorial. Great piece of writing, speaks to some very fundamental truths about our nation. And the other piece of writing I'm going to give you is the lyrics from one of Taylor Swift's songs. And we're going to do some comparison on those two pieces of text, because what I want to know is one more intelligent than the other? Is one more interesting than the other? Does one use more complicated writing or more complex words? And no, the song I'm using is not Wood, if you were curious. We can leave Travis Kelce out of this for now. But it's an older song because I've been doing this challenge for a little while. Maybe I'll update it next time to be a different song. But we're going to start, and the file should be here under Modulate Files. Let me see. Oh, maybe it's actually in the Sandbox itself. Let me. Oh, no, there it is. M8 Lincoln Swift right here. So I'm going to download that file, and I'll throw that on my desktop so I can get it later. And I'm going to open that up. There we go. So I have two strings. I have a Lincoln string and I have a Swift string. Now, the Lincoln string only appears to be 4 lines, but those lines are super long. Okay, those are long lines of text. The Taylor Swift song I just left in its lyrical sort of poetic format. And then I know you'll be excited to see it, some custom functions that do some stuff for us. One is called clean text, and what it does is it gets rid of line breaks and other assorted pieces, and it uses a method called replace. So it's a string method called replace, and it takes this and replaces it with that. So the first argument is what it's looking for. The second argument is what it replaces it with. So it's taking a parentheses, for example, and replacing it with a space. It's replacing all this stuff with a space, and then what it does is it takes sequences where it finds 3 spaces and replaces it with 1. It takes sequences where it finds 2 spaces, replaces it with 1. By the time it finishes all of that, you'll have a neat, clean block of text where words are separated by spaces and there's not extraneous punctuation, which helps with things. And then it returns that. So whatever I put the argument in, and then it sends something back that's cleaned up. This one is a function, as the name implies, that will take a string as an argument, and it returns, look what it returns. It returns a tuple. And that tuple returns a length, so how many unique words there are, and a sorted string of, or a sorted list of strings in that text that's sorted by the length of the word. Okay? And here are some extra instructions and a challenge to create additional functions that work on this. So if I run this code, you can see here it cleans the text, and I'm just operating on the Lincoln text here. Okay, so I'm using the Lincoln text, cleaning it out, getting the length of the total characters. So how long is the Lincoln text in characters? How many words is it? What's the average word length? I can find the average word length by adding up all of the characters and dividing by the number of words. That gives me the average word length. I can find the number of unique words. Okay. or yeah, this is the number of unique words, and this is the unique words. Notice here, I'm accessing the values of the tuple that it returns. This unique words returns a tuple with two items, the number of unique words and a list of the unique words. So I'm putting those into an integer and a list variable. So there's a lot going on here, and I want you to play around with it because it's going to help you understand how some of this stuff works. But what it does is it prints out some of the things here. Oops, but I have to run the correct. Okay, so the Lincoln text has 3,884 characters. The average word length is that. So what you'll want to do as you go through this is try to create the custom function that's mentioned in the comments of this file, but also do some of these operations with the Taylor Swift text. Do some comparing between those two types of text, or those two pieces of text, to see. I mean, who do you think uses longer words on average, Taylor Swift or Abraham Lincoln? I think most of us would probably guess Lincoln, but I think you'll be surprised. I won't spoil it for you, but I think you'll be surprised that Taylor Swift actually uses a similar number of longer words. So I won't say who's higher, but I will say that there's not as much difference as you might think. Okay, we don't judge a book by its cover, right? So anyway, spend some time with this. I'm going to go straight into the explanation for the next part, which is the assignment for Module 8. And I want to cover that, and then I'm going to give you plenty of time to work on both. So we still got almost an hour left in class, which is plenty of time. So before I jump into the assignment, some other things. How many words are there? How would you find the average word length? Can you count the punctuation? Count the unique words? Are there words that are common to both? Can you figure out how you would approach that problem? So you need probably a list of unique words to both, and you have to find a way to compare them. I'll give you a hint. You would use a for loop on one of those lists and then compare it to the other. So what other analysis can you think of that would be interesting to discover about these pieces of text?